Okay, Assalamu alaikum. We will start with topic or term 3 materials. We will start with simple harmonic motion. So in the beginning, for these KPIs, we need to keep this information in mind, which is frequency formula. It's 1 over the period, and the period is 1 over frequency, here in hertz, here in seconds. The units, this is number 1. Number 2, amplitude. It's what? It is half of the total distance between two extreme positions. It's half of distance between two extreme positions. What do I mean by this? Yani it is half of this distance, half d. Okay. So let's calculate the first part for question 21. An object undergoes simple harmonic motion with a period. He gave us t. The distance between the extreme position is 6 centimeter. Okay, what is the frequency and amplitude? We know that F is equal 1 over t, which is 1 over 0.4, so it will be 2.5 hertz. Okay, and for amplitude it's 6 over 2, half the distance, which is 3 centimeters. So the answer is B. For question 22, again same things we need to keep in mind. A child on swings performs 2 oscillations per second. What is the period? Okay, so again 2 oscillations per second, so this is F, 0.2 I mean, so it's 1 over F, 1 over 0.2, so it's 5 seconds. So for the next KPI, which is question 23, I want you to know that this information you should keep it in mind. Number 1, the period for the mass spring as follows. So T equal 2 pi mass over K. Question is just about and you need to substitute. For the frequency, it's 1 over 2 pi square root K over M. And that's it. So let's go to question 23. Question 23, calculate the time period needed. He gave us the mass, which is 2 kilogram, with a spring constant. So he gave us K, which is 0.9. Calculate the time. So he needs T. It's 2 pi square root the mass, which is 2 over 0.9. The answer will be 9.3, I guess. Check it on the calculator, please. Okay, this is the period, and for frequency, it's 1 over 9.3, which is 0.1. Okay. For question 24, a mass spring, which is the same, he gave us the frequency F, which is 0.58, and he gave us the mass, which is 0.9. Calculate K, the spring constant. So F equal 1 over 2 pi, it's K over M. F equal, he gave us F, which is 0.58. 1 over 2 pi equals square root the K that we need over M, which is 0.9. In these questions, for some calculators, I do not prefer to use the shift solve thing, so please do it manually. So multiply by 2 pi will equal square root K over 0.9 square root, or multiply, to the power of 2, raise it to the power of 2 in order to make it simpler. And now K will equal 0.58 multiplied by 2 pi الكل squared multiplied by 0.9. You will get the answer, which is 12. If your calculator is advanced enough, you can do shift solve straight away. Okay, for the other part, the other KPI, it's a simple pendulum, and it has other formulas, which is T equal 2 pi square root L over G. So just note here, as you can see, we don't have G, so the gravity does not affect the spring mass system, but for us the simple pendulum it affects, but the mass does not affect here. So on the mass does not have an effect. This is for T. If you want to rearrange and calculate for L, which is T over 2 pi L squared multiplied by G, if you want to rearrange. So for question 25, a pendulum has a period, he gave us T, determine the length. Okay, L equal T over 2 pi L squared multiplied by G. T, which is 1.23 over 2 pi L squared multiplied by 9.81. We will get the answer, which is 0.3. What is the period for question 6? Again, the period, which is T, he gave us show the length. T equal 2 pi square root L 0.8 over 9.81. You will get the answer 1.8 seconds straight away. So as you can see, it's only a matter of formula and substitution. For this part, as you can see, for the next question 27, for the next KPI, we need to keep in mind that at maximum displacement, we have kinetic energy equal 0, potential energy equal max, and here it's the same. And at middle or the lowest point, kinetic energy max and potential energy equal to 0. So kinetic energy here 0 and max at Y. Kinetic is max, potential 0, here 0 max. Okay. For question 28, for the spring mass system, max kinetic energy happens at center, at the equilibrium. Okay. Max potential energy at extremes. اللي هي at extremes, يعني either full compression or full extension. Okay. So at which position the kinetic energy is maximum? The kinetic energy is maximum at the relaxed position, which is B only. Okay, B only. And this is it for this topic. Thank you.